Alright, starting the second stream of the day, got a HDMI repair on another PlayStation 4. Just to give a brief little intro of what's already been done and what still needs to be done, is that this PS4 came to us after already having some work on it, either from another repair or, to be honest, haven't gotten the information yet if possibly the owner tried to repair it themselves. Not sure, and we'll eventually find out when I speak to them again next. But this HDMI right here has now a pad missing from 1 and 2, which there's still a piece of it left here, but both of these will have to be rebuilt. Not a hard step, just adds a little bit extra to it. This machine actually had quite a few issues. If I pull up the ticket on it, I think we've got a laundry list of work to do. Let's see. Now, from this particular machine, I had already pulled the HDMI that was on there, and that reminds me there was actually a point I wanted to make about HDMIs. This is the one that someone tried to replace it with. And this is the one that we're going to put on it. And some of you may be thinking, whoa, you're going to go from a gold to a silver. Gold is always better, right? Well, it could be, except I'm going to show where buying these is completely pointless and a waste of money. But let's first, real quick, take a look at this ticket. Let's see what we have on our list. We had clean and decontaminate. This was an infestation machine. The board's already been taken care of so that we could bring it onto the workbench. We've got replace disk drive, which needed to be done. The drive on this machine had gone. Power supply needed to be done, probably related to the infestation. Let's see, remove and renew thermal paste. That's a standard treatment. And then it talks about warranty on the repair service. Alright, so now after we had gone through that entire checklist and taken this apart and cleaned it, that's when we realized we did have an HDMI issue with it. So if you take a look at this HDMI, and this is what I want to call attention to. So this is a gold-plated HDMI. But hilariously, the only thing that is gold-plated that's not already gold-plated on this one is the outer shell. And for ground contact, I guess that's a benefit. But there's enough surface area that we don't really need to worry about it. If these fingers were gold-plated, and let me make sure that my camera is still lined up, and it is. If these fingers were gold-plated and this was gold-plated, that would be a benefit. But having this outer shell gold-plated, that's a gimmick. Now, you could say, well, you know, it's gold-plated in here on these contacts, which is where the HDMI is going to connect. But let me show you something. And maybe there are some of these out here that don't, but these are the standards that we buy. And you can look down inside, and you can tell, even at this distance, that there's a gold finger in there. The contacts that the HDMI goes on are gold-plated. Now, on this particular one, you cannot see the back, but they're not gold-plated. They're the same as the other. It's just the raw metal. And that's what we're going to be soldering here. And to be honest, it's probably for the better, because I can't remember exactly on the properties, but I think if they were gold-plated, it would actually be harder to solder them. I believe that's correct. Solder does not adhere well to the gold, which is why the manufacturers did not do this. but where it's making electrical contact connection, or that's the main part. They're all making electrical connections, but this is making a contact only connection. You want to have that gold plating inside where it connects to your HDMI to ensure that even the slightest of connect has the strongest possible connection it can. And that's what gold plating is really good for. It gives you a strong continuity of signal, if that's a good way to put it. So don't buy these for the extra. It's not that it's going to do any harm, but you're paying for this plating. It's an extra step, and it serves no benefit in terms of what you're getting from this. Like I said, if the interior fingers were gold plated here and they weren't on this unit, there'd be a reason to choose this model, but that's not the case. Now, I would recommend that if you bought the standard HDMI and you look down inside of it, and you should be able to tell even without a microscope, but if you look down inside and you do not see the gold plating on those fingers in there, you probably want to send it back to wherever you got it from and find a different supplier. It's not that it won't work without it, it's just it should be there, even on the standards. Alright, so there's several different ways to do this. We could start with first laying down a new strip of copper, but the faster and probably the most effective way in terms of it's not going to, without becoming a very costly repair because of the time, the materials, and the energy involved in doing a, I don't want to say one's professional and one's not, but the kind of repair that would be done in a multi-million-dollar facility where they're charging hundreds of dollars to repair traces on server boards for military and aviation grade equipment. It's just, there's not enough benefit to do that to merit. And you can use your simple wire jumper, which is what we're going to do today with this one, which is this wire that's here. And this is actually a 38 gauge enamel coated wire. I like to use that 38 because it's a little thicker. It's closer to, and I'll show it better when we do a close-up, it's closer to the actual trace line in size versus what I like to call follicle wire, which is used in your your Apple repairs. And that is a much more fine, more micro soldering style line for your smallest, most crammed, packed components, because there's a lot of electronic components as well as wiring on a cell phone. And just here, we'll go ahead and show this, the difference between the two. This is the, what is it, actually this isn't even 0.01, this is 0.02. And to show the difference between the two of them, the 0.01 is what's become more popular with your Apple repair. Well, I should say your iPhone repair. So the top one here is what we're going to use for PS4 HDMI. I don't know the millimeter conversion off the top of my head of 38 gauge to millimeters, but it's obviously it's bigger than 0.02, and now more and more people are trending to 0.01, which is half the size of this one. And you can imagine that is extremely tiny and small. To give you an even better idea, this is the tip of the tweezers. And these are not big tweezers, you can see from my finger. These are fine needlepoint tweezers. And this wire slides in between them. If they're not, I need to rebend my tips because it's too far of a distance there for them to even have a grip to that. And even worse on the smaller. So that .02 wire is just too thin, and although it works, I like to use my jumper wires kind of approximated in size to the component and its trace lines that we're working with. And I have several different trace lines. I think I'm out of .01 right now, but I probably stock about 6 different diameters, and that allows me to run the gamut of any electronic repair that I'm going to get into. Alright, so we got our gloves on. We want to stay protected. We've got our fume extraction running. 2 things that are important when doing soldering rework: if you're going to be using flux, and even without flux, I mean, you're going to, most of your solder does have some type of rosin or flux mix core to it, so it's in there. Probably best to wear gloves. But if you're using flux, you should definitely use it. If you're doing the onesie twosie in your life, is it going to hurt you? Probably not, but if you're doing this professionally, if you're going to be exposed to it all day long, best to glove up. Fume extraction, of course, as you'll see, these fumes will come off. Some of them will still pass. I think I need to change some things to get a better suction without having to have it interfere with our video feed. You'll see those fumes kind of come up to the scope, and eventually they dissipate, and that's because they're kind of dispersing and then being pulled away by our fume extraction, which is basically a vacuum that then runs that gas into a carbon filter so that the carbon can trap it and keep it from going into the atmosphere around us and being breathed into the lungs. So what we're going to start with now, and I was saying earlier, I got a little sidetracked talking about the wire. We could take that wire now and run it and go ahead and basically recreate that trace and run it down through this gap. But because this wire is not flat, it is round, and it's not very wide. As you can see, these pads are wider than the trace itself. And they do sell pad replacements that you could buy, and that's that a little bit higher level of care in terms of doing the exact match, which is not necessary for our purposes today. This will hold and be a permanent fix. The only difference is because it doesn't have that wide surface area, it's going to have some wiggle when we go to put the HDMI down. So to make life easier as a repairer, we're going to mount this HDMI first, and then we're going to tack that trace line onto the top of this rather than underneath it, so that we know exactly which direction it's laying and that we're not getting any bridges. And then we're going to run it back. You could connect it into the line here, but I don't like to do that, so we're going to bring it down to the lower part of the line just to make sure that we've got plenty of space running away. Now, I may have to take back some of my words here for this other one, because I believe this is a ground trace, and we could just leave this one, but I like making sure that these are all connected. The ground was there for a reason. And yes, we have multiple grounds, we have backups. Actually, this may not be a ground. Let's see which one this is. We're going to use some isopropyl, which is the best method to clean flux. Just a little IPA. Okay, no, this is actually not a ground, so we do need to make sure that this one is going to make contact. And I'm pretty sure that if we did not put down a line now, we could take that line and then wrap it over, but this one's running underneath. And I hate running wires over the top of the board and then through to the back. So what we're going to do is we're going to mount the line now. And we're going to make sure that it stays where it's supposed to stay. Go ahead and just use a Kimtech wipe. Q-tips and Kimtech wipes are all you really need to clean a board. I take that back. Q-tips, Kimtech wipes, and a horsehair brush. And there's different types that you can get. You could probably get badger hair or whatever else you wanted, but the horsehair I found is cheap. And these actually started out longer, and I just cut them. I do that so that it gives me a stiffer bristle, and that works better at running into those grooves. And yeah, I'm going to tear up this. This is a lint-free cloth, or a lint-free wipe, I should say. That's what Kimtech makes. These are lab-grade wipes. So we can rip it up, and we don't have to worry about fibers sticking to it like a Q-tip does. And by using that stiff bristle, it allows us to kind of get into the crevices and get it really clean. Now we're going to take back out our enameled wire, which I just put somewhere. But you hate that when you have something that's right in front of your face and you don't know where you put it, but I found it. Alright, so enamel wire. I actually did a repair video earlier where I was working on a pair of headphones for a customer. Not often somebody wants to get headphones replaced because we think of them as something so cheap. But these were $150 headphones, and to the customer they were worth having fixed. And after I got them working again and actually gave them a listen to test them out, they're worth $150. They were Bang & Olufsen, and I gotta say the sound quality on them was pretty good. Alright, so we're going to go ahead and turn on our heat on our soldering iron. And okay, this was actually a point I made in the previous video, is that this, see how that's a pain in the butt? You got to find that sweet spot between heat, pressure, and flux, plus your I went name blank on what this is called. That's hilarious. Okay, this is called solder. Okay, so yeah, I went name blank on the word solder. I would say don't tell anyone, but this is a live stream video, so anyone that watches is going to know that just happened. Alright, so what we're trying to do basically is use heat that exceeds the temperature of this enamel so that it helps us kind of scrape it away. We could use a razor blade, but again, something this small and a razor blade is sharp. it's going to make it where it puts nicks and little cuts in it that'll probably cause it to break. But we've got a nice little bit of flux now on this enameled wire. And you see how I was talking about earlier, this doesn't fill in that full void. So they sell specialized copper pads that would fit this little section. The ridiculous part is for this mixed array of these, which come in different sizes and slightly different shapes. So you'd probably only get like 8 of the pads that actually fit on this board in the array that you need them in. And they want $150 for that. Now granted, there's probably maybe 100 of those little trace pads on that kit, but there's not that many that actually fit that platform. And for 150 bucks, I don't want to buy that. Customer doesn't want to pay for it. And this is where the enamel wire fix comes into play. So what we're going to do is take this wire and I should probably use my tweezers for this. Just going to go ahead and separate that from the roll because it's a pain in the butt when it's on it. It just gets in the way and adds one more obstacle to deal with. Okay. Alright, so now we've kind of got it on there. And this is just my method. Other people do it differently. I also need to fix the tips, which I mentioned earlier, so that I can actually get a grip. There we go. That's good enough for now. You can see the frustration of this wire when you're trying to make it. You get to see the difference of why it's a pain in the butt doing it this way underneath, but when the wire is back-fed like this, you really don't get a choice. Because if we set that HDMI down, I'm pretty sure that the prongs are going to be too far forward for what's remaining on that pad. And I may be being a bit of a perfectionist, but it annoys me if something's not the way I want it, and that's where I like this to be square. Okay, that's where we want it. And I'm just going to add a little bit of fresh flux there. I want to clean this up. So clean the tip, get whatever goop that was on it off. Put a little tint on the tip. And now we're going to go back to holding our wire in place. And we're just going to do a quick pass. These tweezers are so out of shape. It's not actually contacting the wire. Hold on a second. I'm going to have to tool my tweezers up if I want to get this right. And I think this is still going to be a pain. And this is the difference between a cheap pair of tweezers and a finely crafted precision piece. They weld these tweezers at the tip. So basically they're supposed to kind of put them together flush, and then they tack weld them together, and that's what makes the two pieces come together. Well, whoever did the tack welding on this one never actually got it right, which means that one side of the tweezer is higher than the other side. And this is where sometimes you don't listen to your own advice, because you'll hear me say buy good tools. But tweezers are one of those things where, I don't know, I guess I just have this internal ability to come to terms with buying a $30 pair of tweezers. And when one method doesn't work, try a different. So we couldn't tweeze it, but I bet you we can put tension on it. The tip's been sitting long enough that it needed a bit of a brushing. Well, we got this the way we want it. Let's go ahead and add some. There we go. So that's what we wanted to get. Now look at that. And we got a little close to the edge there, so hopefully you caught it as it happened. But we went from a pad that was almost non-existent to now filling in that void with solder. So the wire itself didn't fill the gap, but the solder is able to kind of overfill. And when we sit the HDMI down on it, it's going to kind of all work to hold itself together. You can go ahead and break that part off. And I probably should have done this beforehand, but I need to wick those pads out. And this is where I've said before that I bought this tool and it doesn't really work for this purpose, but that is where, if we were trying to remove, before I laid that pad down, I should have cleared these out. And my normal method would be to heat it up and use a solder wick and basically just extract it. But now, after doing all that messing with this pad, if we apply hot air, we're going to lose that. It's going to fall off. So in an effort to not waste all the work that was just accomplished, we're going to use a vacuum desoldering pump to vacuum out that solder. And hopefully it works, because if not, then I will be redoing that component. This vacuum desolder pump is great for removing solder. Unfortunately, and I've talked about this in another video, the thermal, it's a thermal loss, but there's another word for it, where basically our thermal runaway, as we're heating this up, all this copper across this ground plane is basically just sucking that heat and trying to distribute it and get it off the board. And that's great for removing heat when this thing is running, but when you're trying to repair it, it creates all kinds of issues, because you have a fine line between just the right amount of heat and too much heat. Now, the way this desolder pump works is it's a desoldering iron. There's actually a hole in this tip, and we're going to be able to float over that hole and hit a vacuum and pull all that solder out. So now what I'm going to do is, before I start vacuuming, just so that we hit it with the hottest heat we can hit it with, and the most vacuum that we can hit it with, I'm going to first clean this. And I got to start putting stuff back where it's supposed to go because I have basically a little poke wire that goes down into the vacuum and ensures that the hole is clear before we try to start running a suction through the line. And I stuck it on the top shelf when it should have been on the bottom. So literally, this tool, all it is this. And yep, it did have a bit of a block there, so we're just clearing that block out. Let's see if I can see that. We're just running a straight rod through its opening. And I'm actually going to check our cartridge. I think we're good on that part, but I'm going to dump it just to make sure. Alright, so I'm going to go ahead and zoom back out. It's because it'll give you a better view. Put the tool off to the side. And now I want to be on this as straight as possible. So I may have to come out of view. Let's see if I can tilt it a bit. That'll work. So now we want to allow time for this to heat up and try to heat through the board from front to back or top to bottom. Then once that's done, start to feel that heat with the finger on the other side. We're going to hit that vacuum. And still, yep, see, we might not get the result we want. So it took that solder off, but it's not sucking it through the board. And this may be the wrong tip. I think the tip is a little too wide. So we're going to change that. This is actually a Pace desoldering iron. I chose this after looking at several. One reason was because Pace tips are very cost effective. This is the SX100, and I like it. There is one thing that I'm not happy about, and I could have sworn that the demo version was different, and that is that I found the handle, and you can kind of see it again a little too. Oh, let's do it this way. So I find this handle a little too cheap. It's all plastic, and the bits of metal that are on it are right here in the front. Can't really see it, but just that top. And as this thing heats up, it gets more and more pliable. And I've kind of voiced this opinion to Pace. I don't think they took it that seriously, but there is a local rep, and I need to send him a video, and I just haven't done it. But there's some play into this that I don't think should be there, especially not for, after I bought my starter tips and everything that went in with the kit, $1,000 for a desoldering iron. It shouldn't feel like a toy, and this one does. So maybe I should have spent a little bit extra and got the what's it called, the JVC. Alright, so again, and it's a little out of focus now that I've tilted it, we're going to go flush on the board. we have what's called a thermodrive tip. It's a big head, so it lets a lot of heat build up and speeds up thermal recovery. So basically means the tip can kind of, or the tip that is on there can kind of get to where it needs to be, and it will stay there better than if it was a skinnier tip. But it still has a narrow head, which allows us to get full contact on that pad, where I think the other one was making more contact with the mask than it was with the actual pad. Now if we take a look now, we can see a difference where there's an actual divot, a pocket there, versus here, which is almost flush. So it did make a difference, but I don't know if it's actually going to work. That one we may have actually have gotten all the way through. I think I can maybe see light underneath. But I'll tell you what, we're going to try something a little bit different. We're going to go ahead and refill these in. The reason we do that is because we need that solder there to make good contact with this tip so that it can transfer heat as efficiently as possible to get all the way through that board. And now what we're going to do is apply some hot air. But we're going to go with not a lot of hot air and a very low amount of airflow. I might actually crank the airflow back up. We're at almost 50% airflow. And I may, like I said, have to take this out of scope of, where are we at here? Of what you can see is I need to get straight on this. Yeah, we're going to lose this microscope for a second, but let's see if we can put that back camera on it. Yeah, well, at least you can see that the tip is now pointed on. So what I'm doing is I'm heating the area up with hot air. And I want to do that so that I basically get that solder nice and wet all the way through the board. And once it's a little bit hotter, or the board is warm throughout, now when I apply that tip down to it, that solder should be much more ready and eager to wick away. And actually that is working. And probably in the time that it took me to change to this method, I could have just redone that wire. But it's nice to show some different techniques. So if we come back now, we'll see that this is completely cleaned out. It just sucked. Well, there's a little bit of a roughness down there, but we can fix that. One thing it did also do is kind of caused our solder to now bead back up on this little weld here. Let's go zoom in on that. But you know what? I'm okay with it. Even though we don't have that thicker blob, still got a good solid joint. One thing we will do though is take a razor blade and we're going to trim that edge that is hanging over onto the ground plane. So see here, here's ground, here's our trace. We don't want the two to be one. And I did have the curved tips. I actually finally bought those and picked them up from Louis Rossman's website, actually. It saved me the hassle of having to wait to have them ordered from China. Because having that bent tip allows me to get that hot air up under the microscope without having to have it standing up, just like I have to have the desoldering iron. One, it's more natural and is easier on your wrist, but for the purposes of making videos, it would make it quite disruptive to having the camera watching while trying to blow hot air directly onto a component. It looks like we need to flip this, because down in this hole, let's see if now, yeah, you can really see it now. So right down in this hole, it looks like that we have some copper pad wear on that bottom side. So we're going to try to fix that. Now the question is it just solder or is it an actual, we need to clean that so we can see better. Get a little flux down in this. Are we actually, yeah, you were looking at the right hole with me, okay. Well, basically, I'm doing it this way because what we have is copper from the inside of this. Think of these like rivets. There's a copper channel that goes straight down and through, and that was damaged in the previous replacement attempt. With all this kind of soot-like that's coming out of there, it looks like probably some of the board material was burned as well. Dark kind of, I mean, it looks like burnt charcoal because it's actually, and again, I'm going name blank. That means it's time to have dinner. Otherwise, my brain starts acting loopy. But that dark kind of residue that's pouring out is actually charred. Like, see here how that kind of looks. You can't actually see it right there, that edge, how that looks dark. That is the fiberglass part of the board that as it burns, it becomes, what's the word I'm looking for? I mean, it is a, it's a soot, but it's carbon, kind of like a carbon deposit. So it can be conductive, and in this case, it's not going to hurt anything if it was, but that's where you'll hear other people talking about, you know, when the board gets burned and it's actually creating a electrical bridge between components because it was burned and charred so bad. Alright, so I think we're going to try a little bit of flux and wick to see if we can soak up some of what is in there. We got to turn our heat up as much as we can for this. And we'll probably even add a little hot air. See, if I wasn't using this angled tip, I wouldn't be able to have the camera over this spot because I would need to have this inverted and pushing that out of the way. Now I could just hold it at an angle, but man, this makes it so much more simple. When I wasn't streaming, it wasn't really a necessity, but I guess more a convenience because I still could have used it. But with streaming, it became a necessity. And my intention was to start streaming, well, not streaming, but recording and putting them on 5 years ago. And that never really happened because I bought the wrong setup. I had a 14 frames per second USB camera when what I really needed was an HDMI. And at the time, I just wasn't that motivated to buy another one. But it was time for a new, better camera, and HDMI was there and wanted to stream. And I will probably only stream because I'm lazy. I'll say it. I don't want to have to edit videos. I don't mind if somebody sees me make a mistake. I'd rather do that than have to do the extra work of editing and splicing and critiquing a video. So you're going to only get it from me in its raw and gritty state. If you're looking for pretty and all kinds of fancy frills, about as fancy as it gets unless I add a stream deck to start punching up stuff, it probably won't get any fancier than my little banner there. And my mouse kind of ran away on me. My desk is not exactly how I want it. It's a work in progress and has been for quite a while, but I've got, I think, my final plan on my new desk, which is going to be custom manufactured and should make life a whole lot easier in terms of storage, having everything where it's supposed to be, and having cutout slots designed specifically for the way I like to work. So once that finally comes about, and it'll probably be July, August, somewhere in there, when that desk actually finalizes its order and gets shipped out from the supplier. And I'll make a video of the assembly of that, so that's something to look forward to. Alright, so our contact is still on. Our contact is still on, and we're ready to go to the next phase. Had to shut the door to block out some background noise. Alright, so as you can see now, and the reason why we want to have these holes cleaned, and I've mentioned this in a previous video, is we want to have unobstructed access to be able to kind of wiggle and wobble this HDMI until it's right where it needs to be. And we may not be as ready as I would like to be. Nope, just needed to use a little force. Let me back this back up. Alright, so basically at first it didn't want to go in all the way, and I just had to kind of pick it up and pinch it down because we had cleared those holes. And the reason why, in my opinion, it's important to do that is that if you don't clear them, you're not going to be able to line up these pins properly. And if you get to, a lot of people you will see just kind of move and wiggle them here, and that's fine, you can do that and you'll see me do it. But if they're too far, like this one, I would wiggle. But if they're too far out of alignment, you could actually have a bridge on the underside, because remember, you're not seeing the entire pin here. A part of it is back here. And it's doubtful that it would cross that gap, but I actually I've done it myself, so I know it. You can be twisted enough on this to where you can push these all you want to line them up. But if you're not square, or you're far off from square, you're still going to have issues. You see, this is what we got to watch, is that this guy stays where we need him to be. And I've got to go back down to check this. So we're going to go down, and then we're going to come out. Alright, so I want to see, why are we wiggling so much? And is it an issue? I think we need to be a little more flat. See how we have this nice big bump? Put a little flux back on. We're going to try not to get too crazy. And this is where I've said before, what is the right amount? Is there too little? Is there too much? Well, that answer is it's for you to decide. Everybody uses it differently. You're not going to harm anything other than if you flooded this entire area. You might allow some components to float away if you were blowing hot air everywhere. But flux is not going to damage the part. And she wants to put up a fight. Okay, I think if I fight with this too much, we're just going to lose more of that pad. So I'm going back to my original of where not taking care of those holes to begin with has caused us a little bit more grief. And I think, nope, I still have it. Alright, this is not the best way to do it, but I can't use the fiber brush because of the closeness to that. It's going to cause it to probably tear away that pad. So we're going to try to be very careful with a razor blade. And I'm going to go with our thinner diameter solder at the moment. I'm just going to wet that up. And it's amazing how that works. It withstood all that shaking and pulling and scratching, but the second we do a little baking to it with a soldering iron, that nice loose pad just ran away. So if I would have got those holes before I laid down that wire, I would have saved myself this headache. because we were perfect until I had to heat that up. That's okay. We're going to go back now and take care of all of that. Alright, so we go back to our enamel wire. And remember, because this has this coating on it, we need to use flux and solder and heat to remove it. So we're using the flux that's already on the board. Give it a little bit of a turn. And so what I started to do with this last one, and what I probably should have done in the very beginning, is we're adding an extra, well, not really an extra one now because we lost our front part of our anchor, but I should have tacked it in 2 places before. You can't really see that. Okay, so we've adjusted. Now you can see. So before we had pad up here, this part will definitely not be accessible to the prong that comes off of the HDMI. So here, we could have tacked it there, which is what we did originally, and then also here, which is what we're going to do now. And we would have had a dual kind of anchor on that wire. And those are usually really helpful to have, so it probably would have been ideal to start with that. An additional benefit of having it anchored to that back hole is that we're further away, our anchor point is further away from where we're going to be applying heat when we try to bond the pin as well as, or bond the pin on the HDMI to this wire. And because this side is soldered, it's directly sturdy to that board, so we can just kind of twist that wire until it says, yeah, I'm going to come off. And again, if we look at, let's go a little closer. Alright, so if we look at this hole, which it looks like a hot mess when all this sticky icky is there. Let's just clean it up for the sake of the video so that you can see it. And we're going to get a fresh Q-tip. So I'm thinking just to make this a surefire win, I've already got it clean now, I might as well as just seal this component so that wire won't drift. Well, seal this trace rebuild with some mask, and it'll give me a chance to test out on video, which it's not finished, and I'll probably end up buying something different, but I bought some UV LEDs, and I don't know what kind of crazy LED this thing is. One, I think they way overcharged me for it, because I thought I was getting 4, and they used some tricky verbiage, go figure, from China, to give me 1 with 4 LEDs in it, but the way they had it marketed was you were getting 4 of the chips that each had 4 UV LEDs on it. But it is a 14 watt, and the thing gets so hot on 14 watts, or 14 volt. It gets so hot that it requires a heat sink and a fan. Now, I don't have the fan hooked up with power, so we're just going to use the heat sink, but it'll be fine for how short we have to use it to bond and cure this solder mask. As long as I haven't misplaced that, because again, I'm kind of moving stuff around on this desk and not putting it back where it's supposed to be, which is one of the reasons why I'm ready to get that custom desk. This is when we need the soundtrack. Where did you go? I think this is a common issue with repairs because you only have 2 hands and you're juggling between so many different things. You grab something, you use it, but it's a multi-stage process. We don't have assembly lines where machines are running these things, step 1, step 2, step 3. So when we move to the next step, we tend to set an object down and have every intent to put it up as it should be once our hands are free again, but we need to move on to that next step, which requires us to then change our train of thought, and it seems like you never end up coming back to the cleanup process until you need it and you realize you can't find it. So you basically start to clean up everything, and then for a day you're organized. In fact, let's move our razor blades back to where they're supposed to go. Get my hand out of the camera. And got one more. There we go. A Q-tip that is dirty that we just used. Let's throw that away. And we're going to give this a couple of more passes, and if it's not located, then it's not necessary. It was just an extra precaution so that as I'm sitting here and talking, I don't make a mistake that causes me to have to back up and redo something, making this video longer than it needs to be. And like I said, that's where in a live stream you're going to get it raw, you're going to get it gritty, and basically shit's going to happen. But I refuse to be a guy that's going to sit there and spend 2-3 hours editing a video so that everything looks picture perfect. To be honest, I admire the people that can do it, but it is more time than I have to give. I did find something I wanted to find. That can go there. And the funny thing, I'm going to find that I did put this up, I just put it in the wrong drawer. and that's why it's not popping right out at me. Oh, there it is. I actually threw it underneath to block it from sunshine when I should have just put it back in its drawer. Alright, so now we need to get back and focus on the camera. We have, where are we? So we are right here. And let's see. Let's go ahead. For this, we will zoom out because you don't need to see the finer detail. We can come back into that. And again, this process is normally a lot faster, but as you're showing it on a video, it's going to take more time. So if you're looking to get proficient and do this yourself, I mean, you can knock this particular repair out pretty quick. And I don't like putting this on the board directly, so I'm just going to put it down here on this masking tape. Alright, so this is called solder mask. And what this is actually the same green coating that you see on the board now. Obviously that color, oh, you can't see it. That color is much darker than what is on the board, but that's because there's a copper layer underneath, and when you just have a thin layer, you're getting some see-through. And it kind of comes up with this in-between green, yellow kind of merged color. But to apply this, I like to get a gob of it. And one, we want to make sure the resin that makes this work is thoroughly mixed. I just do that by stirring. And it takes very little. Like all that I just poured was just because that was convenient. I kind of gave it a little thumb pressure and that's what came out. But the amount that we're actually going to use is so infinitesimal. Like that's probably more than what is necessary. And this new LED bulb, as I said, it's not going to take long, is the UV, whatever it's doing different, and that thing just kind of, it dries it right up. We're going to get it over the top. We're going to get it. What we don't want to do is let it, in fact, I'm going to go ahead. This is where I said it's more than what is necessary. We don't want it to cover our wire. We want it to cover and bond the jointed area to the board. I probably should have cleaned that up before I started spreading. And again, I wouldn't have had to do extra work, which is what we're going to have to do now. Oh, I didn't show that. I'll tell you what, since I didn't, probably should have had these lined up. Let's just go ahead and clean it, because I didn't like the way it was anyway. Son of a bitch, that alcohol dripped over. Okay. Excuse me. I'm trying, I love my 4-letter words and all the other ones. I'm trying to make these videos as friendly for everybody as possible by not using them, but they're going to slip out. So if you have a problem with a few swear words, you probably won't like this channel. Alright. So that's much better than last time. And now, I did a very small glob, but look at all of that is still left. And we're just going to wipe that up. Next, we'll do the curing process. which within a few seconds, it's going to harden this resin. And make it so that it is a solid connection. Well, a solid, think of it like a Band-Aid. It's a covering to protect it from electrical connections that are around it. We don't use heat to dry it and make it hard, which some resins do. But this is a UV cured resin, which means we need to hook up this way overpowered LED. I literally just had that. I stuck it up top, so I was moving stuff around. So, I'm not sure if you can see this, but I actually currently just have this mounted to an Xbox heatsink, but this is the LED. And I'm not happy with this company. Cree is not the one, that's just who makes that board. I will not recommend them to anyone. They don't make the LEDs. All they simply did was buy these LEDs, which individually are cheap. They then mounted them to this 4-quad kind of setup board and then sold them overpriced to me using tricky verbiage that made it appear that you were getting 4 of these chips that each have 4 LEDs versus just 1 chip with 4 LEDs. It's kind of shady, but when you're dealing with these overseas suppliers, it's par for the course, basically. Alright, so I haven't put this in a case with its own power or anything yet, so I'm actually just going to get power from my DC power supply, and like I said, this is 14 volts. This is what this one runs on, and this thing gets hot. I mean, it will literally heat up this heatsink. But it doesn't pull a lot of amps. And this is the more expensive UV LED. It is the, 360 nanometer is the spectrum that it's on. So we connect its ground and connect the positive. Well, negative and positive, same thing. You better be kidding me. This thing does not work. Is that the wrong one? I also ordered 2, a different type, a cheaper type from this company, and one of them did not work. Again, one of the reasons why I'm not happy with them. I thought I had the right one, but I might have reversed them. So let's check this other one. And see if it fires up. And if it does, then that's exactly what I did, was I put the wrong one there. No. So now neither of them work. Well, way to go. Way to go, not wait. Way to go, China. not getting anything. No. So I'm basically just trying to force this to work. And I don't see it pulling any amps. So looks like this piece of junk may have blown after one test use. Let's take a look at it under this scope. We're getting to do all kinds of fun stuff in an HDMI replacement. So this is the LED. You know what we're going to do is we are going to individually power up these cells and see what we get. For that, we're going to change connectors here. I did have alligator clips hooked up to my power. Oh, wait a minute. It may not be a problem at all. Alright, so I might have to apologize that at least this one still works. My alligator clip to the supply may have popped off on me. Alright, so we're going to start at 12 volts. Start slow and go high. And this would be the benefit of having this basically on its own management so that it's not having to be changed and we know that it works. Alright, so now we should be, I'm at 13.8, we should be getting something. At this point we get nothing. Make sure we got connection here. Let's check this with a voltmeter. And see what happens. Always bumps in the road. It's always something to be done. I could use my original, but it takes so much longer. Basically, it's like a nail cure lamp for UV. All right, let's say we got 12.35 volts coming in, which is what I'm reading there. I'm not sure if those are contacts there, but I'm trying to see if we can find. No, those have got to be contact points. So it looks like that's the contact for negative. There's positive. There's positive. Now we're at 7 volts. Seven volts. 9 volts. 9 volts. 12.34 volts, which is what we have right here. And that's just our thermal paste. We're going to kill power to that for a second. Let it drop back down to 0. And see if possibly these just got kind of loosey-goosey on their connections. What we'll do to do that is just add a little flux in between the LEDs. I want it to basically just flow under. I have a data sheet on them, so I don't know what the specs are, but they're not working, so who gives a crap? So what I'm wondering is if potentially they got hot enough to kind of mess with their surface mount connection underneath. And here's another benefit of this. I wouldn't be able to do that with a straight one. And let's now crank that airflow up. Figure that would probably happen. Alright. Doubt this is going to change things for us, but it was worth a shot. So you can see that was nice and sizzling. I've said this before, but even no clean flux has to be cleaned unless you actually heat it up to the point where it dehydrates and becomes a hard kind of a, I wouldn't really call it a resin. Well, I guess it would be a resin, which is the remaining, almost like how when you could take sugar and heat it up or boil like kind of like a liquid sugar, and if you keep doing that, eventually you'll reduce all of the moisture out of it. I guess that's a good way to put it. You're reducing the moisture until it's no longer wet. It becomes a hard kind of crystalline-like structure, and at that point it can no longer absorb elements from the atmosphere, dust, particulates, solder, and if it does do that, then you run the risk of it being able to short something. So no clean flux is only no clean if you've heated it up to its curing point And at that point, then you can leave it as is. If you have not done that, then you should clean it. It may not be conductive, but the stuff that will stick to it will be. And clean up our little section here. And you remember that little horsehair brush that I told you about earlier? Another time this becomes handy. It can get down in those edges that the Q-tip cannot. And we're just going to kind of clean some of that gook out. Alright. So it does look like we got those little undercores to melt. They do appear to be laying more flat. Now whether or not this one is more flat than it should be, and this one as well, whereas these are kind of sticking up, and we can see the solder balls underneath them. I don't know if you can notice that, but one side C shows solder on the right, the left does not. The left does, the right does not. It's kind of funny how they're the ones that are diagonal from each other. I wonder if that's also part of the issue, is maybe those are the main ins and outs. Are they? Hard to tell without removing those chips to see exactly what the wire diagram is doing, but I'm curious. Alright, so we're going to go on a voltage. I'm covering this up just so that I can see it, the light kicks in. So I could also feel it. I'm not getting anything from this. I think I got bamboozled by the seller. It came on literally once in testing and has not since. So what we're going to do now is go back to my original thought, which was to try to power the individual cells or the individual LEDs by sending through them 3 volts, but doing it directly and on their site it says that these do take up to 14 volts or something like that, but I mean they're supposed to be individually 3 volts, which would be a cumulative 12. However, when I initially put 12 through them, it did not engage the light. But again, that could be part of the defect. So the question is, it does look like, let's check this real quick, which one's positive, which one's negative. We're going to go to continuity mode. We have continuity. You may not get it through, let's see what happens here. Okay, so there. But this is negative, and it's on the same line, and this is where I'm not as familiar with diodes to know exactly how that comes into play. That is negative. That's next in line. So, negative. positive. Alright, so it looks like we may be in series, which we definitely got to be because it's a cumulative voltage. And that would explain why we only get contact at this for positive, and here for negative. So we got power coming in on here, and it then goes through so positive here, these are not together. Either that or it's just coded, because you would think this looks like it's straight through to that bar. Okay, so confused by that because it doesn't make contact there. Somehow that is separate, so we don't have continuity straight across, because we are definitely hitting that. Oh, this is gelatinous. Look at that. It's wiggly. Not sure if you can make that out. Now let's come in a little tighter. Okay, so can you see that from the video? Yeah, you can. That's Jello. I wonder if in between these 2 points there's a breach there. Alright, so we know that this takes from here to here. All LEDs are a diode, so I guess what we should probably do is switch over to diode mode and check our 2 points. None of which give me any satisfaction. Well, I've gotten so sidetracked here because now I'm doing an LED repair instead of an HDMI, but tell you what, while we fool with this, it would probably make good sense for me to remove the board and let it go up under a traditional. So it would have already been done by now. So we're going to continue to play with this while that board is under the old school UV lamp, and see if we can get readings anywhere across these LEDs. Which, by the way, they charged $15 for this one chip, plus shipping. It was about 20 bucks. And that's where I thought I was getting 4 of these. Now, I gotta say, when it was on, for the one test that we gave it, it worked amazing. Obviously, in its cooldown cycle, it blew, which it shouldn't have. If it could perform while powered on and generating heat, it should have made it the rest of the way, but nope. And I think that just goes to show that the company that did it probably did something very poorly. Let's see what this other one does. I get nothing on diode test. Okay, here, finally I get something. This is giving basically just a straight through continuity. I'm getting zeros all the way across on the diode test. So, by just putting a hell of a lot of pressure there, we're getting continuity. And you know what? I forget. This is one of the reasons why I thought about buying one of Dave's multimeters, because it has selectable diode currents, and I possibly am not running a high enough voltage to open its gate, because this multimeter only runs in like a low voltage diode test. Forget what it is, but I want to think that it's less than a volt, maybe 1.5 volts. So we get on, if you can't get that, let's do ohms. I got something there for a second. Alright, let's try putting power to the other. And like I said, we're just basically using this right now to kill time until the other UV cure, which usually takes about 10 minutes, versus if this one would have worked, it would have been done in about 10 seconds, which is why I preferred to use it. Now, I wasn't going to bother filing a dispute on these, but I think now it's required. So between the two, I've got 35 bucks into these two chips. And it's ridiculous that neither of them are working now. And I get nothing. Okay. So I basically just tried it with a different multimeter that I know is better at. It's the one that I use for testing transistors. It's got a little bit more of a current push, which helps in these situations, and it does absolutely nothing. Same result. So I think we have an issue. Man, I'm just trying to. Those are actually flush to the board, whereas that one at least has those two that aren't. And it does look like there's a ball here. Let's use good old-fashioned. Put this back in the view so we have a little slightly less boring video if you can see what's going on. We're going to check out some LED just to make sure we're following all the steps. So just taking a look on Google, making sure that contact between the 2 points is correct. I mean, it should be making contact between 2 points, and we should light up that LED. I did say I would try additionally doing, I need to now switch back an individual power on, which requires us to go in at 3 volts. We are at 2.9. Let's do 3.2, 3.1. Well, that worked. That works. That one works. Okay, that's really weird. It looks like all the LEDs are lighting up. But they don't light up. When we apply power this way. So let's go back and tweak this voltage. We're going to go to 12 volts. When we try to send 12 volts that way, it does not work. When we try to send 12 volts this way, it does not work. Which makes me think that there is an issue somewhere with this chip. Which you would think would be so simple and so basic that it would not have a fault. I wonder if we do continuity. Okay, so we don't have continuity. Oh yeah, we tested some of that earlier. Where is our break? Well, we know we were also getting voltage through our different ends, such as, I think this one is our lower rated one, and it will function around 8 volts. So what we're going to do is try sending power back through, oh no, this is our other one. Let's try it again on this one. Which we're going to try with 8 volts. And let's actually, we're going to turn down this light. And this will probably get dark for a second, but it'll help us see if we can pass any light through here. Alright. Alright, so it's telling me I've got 8 volts. But I only have 5 volts there. Let's just go with 5 volts. So here I have 5.82. I've just adjusted the power supply to, it says 5.7. Obviously not 100% accurate. Now we're at 3.73. 3.73. 1.82. And this just confirms our in series. As it passes through these, it will get lower and lower. And now we're pulsing. So we're going to now crank this back up. We're going to go with 9 volts. And at entry, we've got 9 volts. Our next step through the LED, we have 6.79. We're down to 4.51, 2.24, and 0. Okay, so we're going to take it up to 12 volts. Oh, wait, holy crap, we got a light. Does everyone see that? That is so faint, but it is lighting up. So we're going to increase this so we get a bright light. Actually, we want to go back down because we're going to use our coarse. Okay, so somehow we auto-magically fixed this. And you can see that LED lit up. And I'm going to go ahead and disconnect power. We are going to turn back up our backlight, well, our LED light on our scope, which that is awesome that that is now functioning again. Not sure why it would have ever stopped functioning, but it did. And we're going to now mount this back to this Xbox One heatsink, which I guess you can call that kind of like the beta for me getting it to where it doesn't properly thermally conduct or overheat. Okay, so this was on the traditional heat lamp, and you can see, or sorry, not heat lamp, the traditional UV cure. And you can see now, this is pretty much a solid, and you couldn't see it at all. But you can definitely see that one. So this went from being a liquid to a solid using the UV cure. But what I want to do is see how solid are we. And I think that darker green still has some wetness to it. So what we do now is take our super bright UV and we have that now shining directly above it. If I turn this light, actually you can see on the secondary camera how it's now blue underneath. And I don't know if it was noticeable through the camera, but it's weird how these super bright UV lights work. When you look at them, the white coming off of the LED is actually, the light coming off of the LED is actually white. However, as you can see from this part where my finger is in that top right corner, that light, when it refracts off of anything, especially white objects, it is blue, which is what we all know black lights to do, which is basically a UV light. So I found it interesting that it produces a white light visibly to our eyes, but then when it refracts, somehow that spectrum becomes that blue black lightish color that we all know. Whereas the old school tubes, I have one where it's not an LED driven unit, it actually uses the fluorescent tubes with a UV light, and they appear to be blue. They're a little bit less blue than the black lights people have in their home. Again, something to do with spectrums, where it can be a pure white, visible light, or it can be a blue or a dark violet color. But yet whenever it reflects off of something, it's always going to have that blue tint. I thought that was interesting. Alright, this is way more than enough time we've given this. Let's see if it appears. To me already it looks, you can almost, it appears like it almost stands up a little bit more, and that to me is it has a higher level of hardness. And that's where that spectrum of that UV light, it is, at least in that sense, very good at penetrating through these resins and making sure that it cures not just on top but underneath. In fact, when I did testing initially with this, I used some very thick layers, which using the old system would never actually be able to cure. It was where you could take your tweezers and just like we were able to bounce off of those LEDs because they had the gel covering, you would have that kind of gelatinous, kind of jiggly, there's a wet liquid underneath that top shell and cluster, and that is no longer a problem with this new LED. It can actually penetrate thicker into the layer of that resin and cure. So if you wanted to build up a really thick kind of protective base, those are what it's going to take to cure it. I'm just turning this power supply off so that we're not, one, wasting power, and two, potentially going to shock something. Alright, so now we can finally move forward in this repair process. So this video got a whole lot longer than expected. I think my last HDMI video was 45 minutes, and if I wanted to do this as quickly as possible, I've knocked these out even with one trace. Two sometimes can take a little bit long. Well, they're obviously going to take a little bit longer, but usually when there's two traces, I don't know why I always run into one of those that is problematic. But I've done an HDMI repair and a trace replacement as quickly as 15 minutes. And that's from removal to component on. So it can be done fast. Now, if I was doing all of them in 15 minutes, would I have some failures? Yeah, probably, but nothing that I wouldn't be able to fix after the fact. And so from all my playing around, I have stuck the oh, there it is, the HDMI somewhere, I thought, and wasn't sure where it was, but I have it. Okay, so this little coating should help us retain that wire, even though, and you'll see the difference in how this other one is done and why it's not necessary to do that once we get started with this, or once we get to the point of replacing that other one. Now, as you saw before when I tried to put this down, or maybe you didn't notice, but I'm trying to get this in focus for everyone. There we go. That the wire, because it was allowed to kind of jiggle on its own, it was actually leaning out to the side. We just want to make sure, yes. Okay, so we do have contact there. So you can see, here's the wire. It is still on the back side. Probably I would have liked it to be a little further down this way. I probably could have waited to nick it away until after it was mounted, but I did not. So could it have been done, in my opinion, a little bit stronger? Yes, but is it still going to work this way? Absolutely. And in fact, just to make sure we've got a nice good coating to compensate for that, now, and this will also help to demonstrate, before, if I would have reapplied heat, the amount of heat that would have traveled through that thin wire would have taken place so quickly that it would have freed this back here. But now because we have this coating, we can actually apply that solder. And you see how it wanted to move, but this back here is bonded and it's not going to be able to free itself like it could have, or like it did before. So we get a more tolerant fix, is a good way to put that. Alright, so what I like to do when I'm doing this is, one, we want to have some flux down here. And you can see we're lined up. By having those holes completely open, it gives us the benefit of being able to line ourselves up with those pins exactly how they should be. And what we're doing now is just making sure, see how that wiggles up and down? I want to make sure that we're flush on these contacts. And then I like to just start and get a few of them anchored. By anchored, I mean soldered. And looks like we're going to need a little bit more solder on the tip. We're going to clean that up a little bit. Alright. So now we're making progress. And you see that bridge that just happened? They will. Don't sweat it. Don't be the person that has to fix a bridge the second it happens. In fact, those bridges will help you, because what they do is give you some extra solder that as you drag, you'll be able to kind of wick it from one pin to the next, so you get all your pins filled. And to be honest with you, this is as much as we want to focus on before. Basically all we're trying to do is get this to where it has stability on these pins so that it doesn't slide. Now that we've done that, we want to work on the mounting pins, which go through those ground holes that we cleared out earlier. So we're going to get some solder in here. And when we talk about this rosin, mildly activated. So the rosin that's built into this core, you see how that got wet? I didn't actually put any flux on these outside edges. So all of that came from within this solder. And then we're going to back that up with some hot air. And this tip probably could be a little thinner. Let's go on this side there. Rossman was out of the thinner tip, so I was only able to order the 2 larger sizes. To be honest, I will probably use these the most, and I would probably have little use for one smaller. but in this particular section it would have been useful. Now that I've got that kind of started on that side, I like to flip over to the back. And basically, I just want to make sure that my mounting pins that ensure that the stability of this HDMI is strong and sturdy before I start finalizing all of my solder joints. Because let's say I had soldered it and then for whatever reason I need to kind of get a little more aggressive with heating this up. And I have done this to where I applied hot air through the back and it just slid on me. It moved around, and I had spent all that time soldering the pins, getting them just right, only to have to remove it because the pins were no longer aligned. So making sure that that's done before you start committing to getting everything perfect here, it's probably going to save you some time in case a boo-boo happens. And they do happen. They happen to the best. Nobody's a perfect solderer, except for maybe one of those $100,000, $200,000, $500,000 soldering machines. Maybe they can do it perfect, but I know humans for damn sure can't. Just applying some flux to kind of clean up those solder joints, make sure none of them got cold, cracked joints from overheating. It's weird that we call overheated joints cold joints. But that is what they're called. Now I'm going to prop this board. As you can see, I got it on an angle, and that's going to give us a better view on that camera, as well as also me a better view of each of these pins. Now remember, there's still one of these that has no pad underneath it whatsoever. So we've got to jumper that one. As well as clean up this little bridged pin setup we got going on here. And there's several ways to remove bridges. I always have said that I like to try to avoid using solder wick if at all possible. It's not that it doesn't work, it works very well. But the problem is that it works so well that it pulls all the solder out, or at least more than you really want it to. And you'll probably end up seeing that on this one. So I'm thinking we're going to have to use some on it. Alright, so what I'm trying to do now is get that, because we know that that connection has been sealed using the mask, we can be a little bit more aggressive with this as well. I'm trying to force that pin to get saturated with a nice, just like that. See how I took that bead on that pin, and now this one's following suit. Well, that time got a little too heavy-handed with it. And there as well. And there as well. That's where you have too much solder on your tip. So when you come over the top, it really wants to suck it on, but these pins are so close together that it's not going to be discriminate. It's going to get it on both of them, which is that's where the drag method is very effective at keeping your solder where it's supposed to be. So we're talking about different methods. Now, for this to be successful, I might have to turn up heat. I need to basically be at my max. So I want to get real hot, real quick, and whisk that solder out of there. So it looks like it pulls. But I think we're going to be faster if we use this. So, as I said, you will see some solder wicking today. The solder wick helps on two fronts. It one helps to dry out the excess solder from the tip, which then allows it to want to recover more solder from our pads and our legs. Now we're going to have to clean that. That's just way too much gook. Once it starts to brown like that, just go ahead and clean it up. Otherwise, you're not going to see what you're doing. You're going to make contacts worse rather than better. You're going to bridge more joints. And where some of that gook was coming from is the downside of that protected plastic back. It's no longer the open pins. Is that often at this level of size, you're going to be making contacts with some of those pins. It's just hard to avoid. And I'm going to try to get in a little closer, give you a little better of a view. There we go. And there was a bridge on this one that I'm tapping that we just removed. When I say we, I'm referring to you and me, or you and I. You may not be moving the soldering iron, but you're here with me if you're watching, so we're doing this together. Whether you're watching for fun, or watching to learn, or watching because it's your board I'm working on. Alright, so what we're going to do now is tilt, see if we look down, if we see anything that causes concern, or if we're ready to move to that final phase. And I'm pretty sure, and this comes with experience and also better lighting, I don't think you can actually see what I'm seeing. I found out that a downside to this new camera is that, man, it requires a huge amount of light for the sensor to pick up, which is why there's going to be another camera. But there is a solder bridge that you may not notice, but I'm going to try to point it out before I whisk it away. So the solder bridge is right here. And if you look down where those tweezers were, alright, I'm going to put them in, so that's fine. Okay, so to the right of where that tweezer is, you'll see that it almost looks like a little silver dot between the pins, and that's exactly what it is. It is a bit of solder that has bridged those connections. And what we did there was went to the back, we got a little plastic, but we achieved our goal of taking that solder and pulling it forward from the back to the front. And it's much more clear now that that is a bridge. And we can put this back down. Be able to work with that. Easy peasy. Something about that joint where it is soldered, I don't know, it just doesn't seem like it's the best joint it can be. Alright, so now it is getting late, probably longer than I wanted this video to be, and I'm still hungry as I mentioned before. So we're going to do one last thing. I'm not going to test it on this video, but I'll probably go ahead and run the test tomorrow and upload a video just to show that it is working as it should, and that this particular joint here did actually bond and bind to that wire so that it has continuity for the connection that runs up underneath the board. As we saw, that was a through hole, or not a through hole, but there's a via that runs down basically like this. This is a via. So the contact comes out here, but it doesn't go anywhere. Well, see those two little holes? And move it over just a little bit. This right here is a via. Yeah, these two little holes, they run straight down through the board. They come out on the other side. Now, you have different layers of boards. You have single layer boards, which is just the top. You got dual layer boards, which is usually top and bottom. You have triple, quad, 6, 8, 12, however many layers they can get the manufacturer to produce it through. And somewhere between here and the bottom, there could be connections that intersect with that via, allowing it to then travel a path in a plane that connections or ground planes or other things are not already operating on. So if you ever hear me talk about a via, that's what we're talking about. Now, we're going to just slather and lather this thing with alcohol. It's a nice little isopropyl. Nice, shiny joints. If you're soldering this together and your joints look like poop, cruddy, crusty, porous, I mean, there's some unevenness to this. They're not perfect flat planes. It's just liquid molten solder that then flash solidified onto the joint. So I maybe shouldn't say non-porous, because they certainly are. But you get the idea. If your joints look like crusty farts, dried up, and those are supposed to be the bridge that makes your HDMI connection possible, then you've lost your mind. It's never going to work. Or if it does work, it's probably working intermittently, or it's not going to work for long. The saying is, if at first you don't succeed, try again. Well, if your joints look like that, you need to try again. Well, not like this. If your joints look like this, you're good. If they look like crusty farts, as I just mentioned, then try again. And it's not hard to get good joints. Use good flux, use good solder, practice your technique. Alright, so the last thing we need to do is make this bridge. Now, let's back up a little bit just to give the full perspective of what we're doing. So, what are we doing? We have a joint that is bad. We got, see the line here? See how it's not shiny there, but it is shiny here. It's shiny there, not here. Shiny on top, not on bottom. That is where we're missing a joint. How do we fix that? Well, we are simply going to scratch away this connection here. Let's pull back out just for the sake of speed, although this may be an opportunity. I don't think this will work on it. I bought this for this purpose, but it ended up not working well for it, if I remember correctly. And I go, you know what, I'm going to keep it, and I'm going to find me another one for the board, because this one actually is solving a problem I had with cleaning the contacts on BGA pads. But I don't think I'm going to use it because it's not standing out or jumping out at me. And like I said, I've got some cleaning up to do on the desk. You can't see it on the video that way because I intended that. I didn't want you to see my desk is a hot mess at the moment. I don't mind admitting it. You can use your imagination, but I'm not going to show it. So we've got, what is our next step here? We were doing the scratch away. Man, I need to eat. All right. And we're scratching away from this one. Follow this trace. There it is. And some people would go, oh, you're using a razor blade. How dare you? Well, shut up. A razor blade is not going to hurt it unless you're an idiot. And sometimes I am an idiot. Not on this one. These boards are tougher than they look. They can take a beating. Now, you shouldn't go out and beat it just because I said that, because it probably won't survive. So if you beat your board and go, oh, he said it was tough, well, don't expect me to buy you a PlayStation. Maybe I need one of those disclaimers, like you see, where you think, why would you even need to put that disclaimer there? But yet, there's always that person that will do something insane, like try to charge their phone via the microwave. So we just basically opened up a contact point here that allows us to staple, bind, whatever you want to call it, this joint here, this leg, to that hole that we just filled with solder or coated with solder. And we're going to use the same stuff we used before. We're going to use that thicker but still pretty stupid thin enamel wire. Now remember, to make this enamel wire work, we need to have flux, we need to have solder, we need to have heat. I think I just need to add more LEDs to this area because I have a window behind me and the blinds are always down because I don't want the sun in my face. However, the lighting that does penetrate through it is helpful. And I'm going to move this out of the way just because it'll be faster. It obviously lights up the area and adds some extra to what the LEDs are doing. And this one uses a Panasonic lens, this camera. If there's ever a reason of why you should buy the Sony lens instead of the Panasonic, which is cheaper now for obvious reasons, it's because of their ability to access and better utilize light. CCD cameras need light, and the Sonys are using the Exmor, which is actually the same thing that is the most common camera right now in our cell phones. And that's because I forget what the exact term of it is. I'll look it back up so I can say it in a future video. But it uses a different structure for how it receives light, which allows it to actually get basically double the light. Maybe it was quadruple the light, but it is better performing in low light scenarios and requires less added light like we do with this. See, if we turn the light off, you don't see anything. If we turn the light all the way up, you get a decent view, but not a great one, and I could probably make some adjustments that would brighten this up. I think some of this is OBS, because it is certainly brighter on my my display out screen for the HDMI. So some of this is OBS settings, but it still should be a lot brighter. And the next camera that I intend to get, which will go back on this scope, and then this camera will transition to the multi-axis stand for doing like side angles, true right angle, left angle, let's say 90-degree bends, 120, 160-degree bends, 180 degrees, whatever I want to twist it as. It has almost a 360-degree rotation. And so that's why I wanted that stand. But it just, because the lighting actually is better with this very same camera on that stand. But it sucks for repairs. You need a trinocular microscope to do repairs while trying to broadcast on a video efficiently, I should say. Because I can do it without it, and I could have done it just with the inspection cam, but you don't move as fast. It's just something about having the medium you're working with aligned the same way that it's orientated. Well, I guess it comes into like kind of like if you tried to do something off of a mirror, your brain sees things, you know, inverted in that, and with the camera it doesn't even necessarily need to be inverted. It could be completely different. It could be sideways or the other, so your hand goes to try to move in the motion of the screen. And I'm just trying to get everything lined up here so that you can see it as it should be. And it creates missteps, basically. It makes life harder rather than simpler. Like here, with this board and its shape, I'm having to do this a little bit awkward from how I would like to in order to get the shot in on the solder bridge. I think I'm going to get this in closer. I want to see this a little more in detail. And so now, instead of going under, we're going to lay this right on top. Now that is a weak joint, but it would actually still be a functional joint. If I sealed it up and made it stick, that would work. But we're not here to do just what works. We want to make it the best we can make it. So I'm going to get a little solder on my tip. And we're going, you know what? We're going to change tips. We're going to make it not only good or better, but we're going to make it a little easier to make it better by changing to a very fine precision tip. And I'm still using my kind of, it's good, don't get me wrong, this thing works, but it's not the high quality soldering iron. But when the tips cost $3 versus $25, you kind of can't complain about maybe a 30% reduction in performance. But I got to get my Metcal back up and running. Okay, and I got to remember what this tip was. This is it's a funky one. It's like CF-001, I think. And BCF1. So as you can see, this is a much more precise tip than what we were using just a second ago. And the other tip was considered to be a thin tip, but not like this one. And we got good contact with that pin, but that little son of a you-know-what decided to release and pivot. So what we're going to do is get it back lined up. So what we're trying to do is angle it down so that when we put pressure on this, it will line itself up. But I'm trying to okay, I'm going to have to adjust this. So let's get you back in focus because I have myself so far extended out. I'm going to have to test some of the configuration changes and see if I can get a way for me to still not have to stand on my tippy toes to get to the eyepieces to use the trinoculars, or use the binocular part while the trinocular is on the area that we want to work with. So, okay, so we're going to try, that didn't work. Let's try. Okay. Now, okay, now we've got a good solid weld joint to that. Oh, and it kind of got slid up in that corner where you couldn't see it, but pulling it back out, there you go. And that's the problem where I'm like having to slide it across the desk and lean and reach over so that I can see without pushing it off, because it's a little bit out of range for the length of this board. And that would probably actually be where my kind of multi-axis inspection cam would go, be good, because I could actually turn it almost sideways, and then it could be out of the work area. So I just would need to set up a scene, and then we could flash over to it, and it would allow you to see it without it obstructing the way that I use this camera. So what we want to do now is we're going to put this back around to where it's convenient for me and even more visible for you. And I'm going to come in and zoom in because I want you to see this weld. And yes, a solder is a welded joint. Why the freak are you not? There we go. So as you can see, and I'm not going to pull on this hard because the wire will break and that joint will not. But you see me wiggling this, and it's on there. It's not going anywhere. But before we go and staple the other side, and I use all these different terms, so you just kind of have to bear with me as I bounce between them. Weld, solder, join, staple, bind, it all means the same. We've electrically connected this joint using the enamel coated wire. We're going to clean and prep the area for the final part. And notice I'm not just going left or right, because if I did that, it would be like earlier when I was trying to break that wire apart. I would twist it left and right, and eventually it would bend and crack and then separate, which is not what we want to do at this stage. We're trying to repair the wire, not break it. Changed out to a dry Q-tip. The other one was quite wet. Alright, now we go back with our tweezers. And I need my other pair of tweezers, but I'm not going to take the time to look for them. We're going to improvise on the fly. We're going to take a cheap, common cell phone screwdriver. And when I say cell phone screwdriver, I'm referring to it that way because it's the kind they give you for free when you buy a screen to do a screen replacement. which I normally don't do anymore, but I did for an acquaintance. Just to help him out. And I will still do them. I guess it has to be when the mood strikes, but replacing screens, it's boring. One. Two, it's not really that profitable anymore. So I just prefer to let the other guys handle it. In fact, I've been referring a lot of it lately to what is that place called? Batteries Plus. And I don't have any type of arrangement with them. I just know that because they're a corporate store, they usually always have parts on hand, and they can fix a person's issue on the spot. Alright, so I decided to switch back tips. Needed a little more thermal mass to be able to get what we want done, as well as we need a little flux. And the final part of that equation, besides heat, flux, we need solder. Wherever the heck I put that. Right here I've got my last little piece I was using. And so you probably noticed, or maybe not, I was too far zoomed in. Not sure how much of that was missed. But you may have noticed, if it wasn't out of focus at the time, that I used two tools to kind of bend and twist this area here, or this wire, to follow the same trace path. And that's just my preference. I've seen some people just kind of lay them down, other people that have their own methods. And this is, I don't know why, maybe OCD, I like to follow the original pathway. Should call up Kid Craddock in the morning and ask him if that makes me crazy. That weld joint is pretty much done. I'm just trying to make it sexier by filling in that little bit of the gap that it has there. And I think I can actually get that done by turning up my heat a little bit, adding a little bit of fresh new flux, and a little bit of fresh new solder. And that's what I wanted. Alright, so now let's see how much of this we can get into focus here. I was talking about the camera, the light that it absorbs and works with, and the Sony cameras with the Exmor sensor will just use less light to create a more natural look. And you would see all of this much more clear. The next camera that I am getting also goes from, my very first camera was, what was it, a 1 by 1.8 inch. This one is actually a 1 by 2.4, so it is a bigger sensor. And the next one will also open up even more area because it will be a full 1 inch sensor. And that's actually a fully digital USB 3. It won't even go over HDMI, so it'll be interesting to see how that works. And it is supposed to be 60 frames per second over USB, and that's hence why it's USB 3.0, because 2.0 USB, which is the one I got before this one, damn sure can't do 60 frames per second, and not at 1080p. Alright, so we got most of that. I think we got the whole wire in the shot. So you can see I used a little makeshift combo between tweezers and the little iPhone tri-wing screwdriver is actually what I used. It's got a nice fine point to it. Kind of a bad tooling there, but I'm sure that's cheap metal. Okay, so I used that to shape this wire to follow that path. Like I said, that's not necessary. It's just me. I like to be silly. And for some reason, I can't help myself but to do it this way. I follow the path and make that connection. So my wire goes from here, and as you can see, it is still bonded. Comes straight down, turns again, and it's not exactly perfect, but it lines up. We got this other one, and remember that wire is underneath. Now if for some reason that wire was not making connection, would I take this all back off and go redo it? No. At that point then I'm either going to wrap around and over, or I'm going to figure out, and I believe that goes to a filter underneath. Let's see, we got 1, 2, 3, 4, 5, 6, 7, 8. No, so it does not go to that, but it's going to something directly underneath this via. But I would at this point go back and check my documentation, or I would probe around on the back, find out where exactly that's leading to on the other side of this board, and I would make that connection. If it has to wrap over, so be it. I would not take apart all of this work that's been accomplished for that one pin. You would have to be insane to do that. But what I can see the wire may be underneath there. See how, I'm not sure if you can see that, but when I wiggle, see how there's a bit of it underneath? So it may not be connected, but the first thing I would try with that is I would put more solder, give a little more pressure, and try to create continuity there. If all attempts fail, then I would run a separate wire. Let's see if we can figure out if that bottom piece moves. If it does move, then it is our... Actually, that may just be an illusion on the eyes. That may still actually be this. And it is a little tricky son of a... Now I thought we had a bit of a run-over connection here, but we don't. We're good. But this is what you're going to do. You're going to do the exact same things. You're going to question your work. You're going to say, did I make sure all of these are separate? And a better test would be to go through and do a continuity probe, because then we know for certain. But we also want to make sure that these can't move except for the ones that are no longer bonded to the board. Alright, other than that, I'm happy with what we got so far. Like I said, tomorrow when I go through and do testing, I'll probably make another video and go ahead and then post that so that you get the full benefit and experience. This video did go quite longer than expected because of playing around with things like LEDs and other stuff. Of course, it always takes longer to do the repair if you're going to explain every nuance of the steps as you go through it. This is Circuit Repair Augusta, and we also operate for our PlayStation repairs as PlayStation Repair Augusta. You can find us on on either or. All you have to do is add .com to the end. So that's CircuitRepairAugusta.com, PlayStationRepairAugusta.com. It's all the same. If you have an issue with your gaming console, or any electronic for that matter, we probably work on it. Not everything's worth fixing, but everything is worth getting a quote on fixing. Feel free to reach us via text or via email. You can call via phone, but if we've got a hot soldering iron in hand, we're not going to answer. So you will want to most likely text message or email to get the fastest response.